Hello everyone. Myself Sushma Vispute here to cover the next topic of data warehouse, that is OLAP operations. The objective of today's session is to see all the OLAP operations in detail. Right? So today we will cover here all the OLAP operations in detail with the examples. So this session will develop your ability to use these OLAP operations, right, to solve the real world problems. So here actually what are these OLAP operations? In DBMS subject also we have learned different operations that we can perform with the DBMS data. And these operations are insert, update, delete, select operations. But here we can never perform any insert, update, delete operation, that you know, because we use this past historical data for the analysis, right? So only one operation that we require to perform on the database, data warehouse database, is the select operations. So all these OLAP operations are actually divided into 4 different variations, 5 different variations. These are roll-up operation, drill down operations, slice, dice, and pivot. So when we will learn these operations, we will come to know these all are the select operations only. These are the select operations. Only we use the different criteria to retrieve the data from the database, right? From the data warehouse, right? So all these are the variations of the select operations. And definitely if you want to retrieve the data from the data warehouse data, also we need the select queries, right? So here, like your DBMS language, query language, also special language is provided by the different vendors, Oracle, MySQL, right, to perform these operations on the data warehouse data. And this language is called as the data mining query language. Actually, this is not part of our syllabus, but if time will be there, I will cover this in one lecture as a content beyond syllabus, right? So data mining query language we can use here to perform all these select operations, right? Variations of select operations. So as per the requirement, right? As per the requirement for the analysis of this data with the different point of view, we can use these operations, right? So definitely we use these operations for retrieving the aggregated data, right? These all the operations are based on the aggregations, right? As student, you know, these aggregations only help us for doing the analysis, right? And you know the different examples of the aggregation. For example, total sales. If we talk about here the sales data, my subject of analysis is what? Sales, right? So for one of the company, right, all electronics company, I am using here sales data, right? So with respect to different dimensions, right, we can do here analysis. So for analysis we need aggregation data, right? So manager people need the aggregated data, for example total sales, right, for the particular product, right? For the, if we take the example of time, right, so for one time dimension, one quarterly, my manager people want to find out the total sales, right? Then for country, for a specific country, manager people want to find the total sales, right? And for specific product also, manager can require to find the total sales, right? For example, TV item, only manager want to see the total sales, right? So all these operations will help you to retrieve this aggregated data from your cube, right? In the cube already aggregated data will be there. So this select operation will be used by your manager people to analyze the total sales with respect to different dimensions, right? So that we will cover in this session in detail. So here, if we consider the OLAP operation which are to be performed on the multidimensional data, right? So you know, my OLAP is based on the multidimensional data. Now here multidimensional, why it is called as the multidimensional? Not only we take into consideration single or two dimension, but also multiple dimension we use here for the analysis, right? And dimensions are nothing but the different entities, right? That we have covered in actually previous sessions, right? So here we are considering the cells of the shop, right? Data cube for the cells of the shop, right? The cube contains here the dimensions, location, time, and item, right? As we know, my data warehouse contains only the subject oriented data. So my subject for the analysis is sales data here, right? So this sales data contains here three dimension: location, time, and item, right? So with the help of this example, we will discuss here how these these data operations help you for retrieving the aggregated data for the analysis, right? So here when we talk about the OLAP operation, always we talk about the concept hierarchy, right? Because concept hierarchy we require to retrieve the more aggregated data, less aggregated data, right? So where the location is aggregated with regard to the city values. Aggregated means what, right? You know, you have learned in the DBMS group by queries. With the help of group by queries, you can retrieve here total salary of the employee department wise, right? Total number of student department wise, average marks of the student department wise or division wise, right? So similarly here city wise, right? If you take this location as the dimension, here what data you can analyze here? City wise total sales, right? Locations are aggregated to the city values, right? Time is aggregated with respect to the quarters, right? So here quarterly you can find out the total sales, right? So quarter one, quarter two, quarter three, right? So quarterly you for quarter one, quarter two, quarter three, quarter four, you will get the total sales when you apply the group by queries, aggregate queries on this time field, right? Then similarly here item is aggregated with respect to the item types, right? So item will be my one of the dimension table and with respect to different item types, for example TV items, right? Then second, TV, for TV item you can find out the total sales in different countries, different states, different cities, right? Then in quarter one, quarter two, right? For the different items, TV item, then another items, computer items, right? So with respect to the item types, you can perform the aggregate operation here. So in next coming slides, we have to discuss example for the same. Here if I have represented this simple example, right? That we can use here. Actually, the concept of cube is what? Already pre-computed aggregate values will be there in the cube cells, right? So how these aggregate values are calculated in the cube with the help of materialized views, right? Actually it is not part of our syllabus, but student I thought ki with one example, if you remember what values are exactly stored in each and every cell of the cube, that you can remember here. So here each and every cell is contains one materialized view. That materialized view is executed or pre-computed, right? Right, on the data warehouse, right? And with the help of this materialized view. So what is this materialized view? This materialized view query is made up of aggregate operations and join operations, right? So as you know, my queries, those we perform with the data warehouse data, are the complex query. Why these queries are called as complex query? Because this contains the join operation on multiple dimensions, and also not only join operation but also the aggregate or group by operation on the different group by fields, right? So here is the simple example I have put here for your understanding, because you are familiar with the employee and department database that we have learned in the DBMS subject. So this is the simple query. Like that, there can be complex query by considering multiple dimension for the grouping here, right? So create materialized view total salary, right? My name of the view is total salary. Why we use view concept? Because it is pre-computed, right? And periodically, for example, semester wise, yearly, half yearly, this uh, cube can be pre-computed here, right? So refresh fast, as refresh fast is actually used for periodically to update these values, because whenever there will be change in the database, these new values new aggregated values we want on the cube here, right? And that's why this refresh fast is one of the operation we need with the materialized views. As select department name, this select query you all know, right, that we have learned in the DBMS subject. So select department name, sum of salary as total salary from employee and department, right? Why? Because my data is stored in two different table. We need the join operation here, right? Equi join operation where EID, E department ID equal to D department ID, right? And group by department name. So this query will retrieve you the total salary for each department in my employee table, right? So here these aggregated values can help your manager people to analyze the performance of the business growth of the business, right? So as you know, here aggregation is one of the method of analysis, right? Data mining algorithms also we use for the analysis, but this is another method. Aggregate value also help your manager people to analyze the growth of the business, right? So that aggregated data you can represent in the form of graphs, bar graphs, right? On x-axis there can be year or quarter, so y-axis there can be total sales, right? So that is will be the graphical representation of the, so but that aggregated values you can calculate with the help of these OLAP operations, right? So here roll-up operation is the first operation that we are discussing here for the topic, right? So these are the 5 different operations. Roll-up operation is also called as the drill-up operation here. Then your drill down operation. What is roll up operation here? Roll up operation is used to retrieve the summarized data, right? My cube will have already summarized data, but if you want to retrieve more summarized data, then you can use the roll up operation. So this summarized data you will retrieve by climbing up the hierarchy or by the dimension reduction, right? So with one example we will see in the next slide how roll up operation works. For example here a drill, for example, if your original queue contains the data for different cities, right? So by applying roll up operation you can retrieve this data state wise, right? So if you apply the uh, uh, group roll up operation on the city, the next hierarchy will be state, right? So by taking the summation of all the cities for that state, you will get the more summarized data, right? So city-wise data, city-wise total summarized data, you can convert into state-wise data, right? Similarly, state-wise data, you can convert into the country-wise data and so on, right? So roll-up operation will give you more summarized data by applying some aggregate operations. Similarly here, now drill down operation works, but here drill down is the reverse of the roll up operation. Drill down is the reverse of the roll up operation. This drill down is also called as the roll down operation, right? Roll up, roll down, drill down, right? So what is the drill down operation here, right? Here in the drill down operation, we find the higher level summary data we convert into the lower level summary data. Means what? Means what? From the given data in the queue, we retrieve the more detailed summarized data, right? So if you want detailed summarized data, so if it is required, you can create a additional new dimension in the data, your table, right? For example, here my data cube contains the quarterly data. If we consider here time field contains the quarterly data, and there are 4 quarters in the 1 year, right? So Q1, Q2, Q3, and Q4. Q1 quarter from for Jan, Feb, and March, for example, then Q2 quarter for April, May, June, and so on, right? So instead of this quarterly data, if you want monthly data, right? So with the help of drill down operation, you can convert this quarterly data into month-wise data. So drill down operation will give you total sales for every month, right? So it will convert that summary, higher level summary into lower level summary, right? So my higher level summary contains the quarterly data and lower level summary will contain the month-wise data, right? Again, month-wise data, you can convert with the help of drill down operation into the weekly data, right? If your cube contains the monthly data, if you want to analyze, the manager want to analyze the sales weekly, right? So that you can convert into weekly data, weekly summarized data with the help of drill down operation, right? Slice and dice operations are similar to the project and select operations in the DBMS queries, right? So slice operation is used to retrieve the data for the particular dimension, right? And here dice operation is used to retrieve the select the specific rows based on some criteria, right? So slice is equivalent to the specific dimension or attributes that you want to retrieve from the data warehouse data, and dice operation for the based on the some criteria you want to filter the data from the data warehouse cube. So with one example we will see in the next slide. And pivot operation is nothing but the rotate operation. So same data you can see in the different views, right? So pivot operation is actually related to the visualization of the data in the different views, right? So by rotating that data, you can see the same data in a different views. That also we will see but in one example, right? By reorienting this cube, you can see the same data in a different point of view. So what is roll-up operation? We'll see in detail. So this roll-up operation is also called as the drill-up operation or aggregation operation, right? If you see here, this roll-up operation is also called as the aggregation operation. So it performs this drill-up operation performs aggregation on the data cube. As we discussed in the previous slide, aggregation gives you more detail, more summarized data by climbing down concept hierarchies, that is dimension reduction. So city-wise data you can convert into state-wise data. State-wise data you can convert into country-wise data, right? So for this different point of view, you can do the analysis with the help of roll-up operation, right? Then roll-up operation is also called as the zooming out on the data cube, right? The hierarchy for the location is defined as this. As we discussed, city can be converted, street can be converted into city, city can be converted into state, state can be converted into country, right? The roll-up operation aggregates the data by ascending the location hierarchy from the level of the city to the level of the country, right? I hope students you are clear with this one. Uh, uh, Example we will see here in the next slide. See, this is my original cube. This is my original cube. And here, if you observe, my original cube contains the time for Q1 quarter, Q2 quarter, Q3 and Q4 quarter, right? And location dimension of my cube contains the Vancouver city data, Toronto city data, New York city and Chicago city data, right? And this is the third dimension, that is item types. So these are the four different item types: mobile item, modem item, phone item and security items, right? So this is my original cube, right? Already my data warehouse is having this database, right, in the cube format, right? Actually it is a graphical representation, but this data will be stored in the fact table. You know, fact table, this cube is nothing but the representation of your fact table. So you know, fact table contains all the keys values of all the dimension table and measurable items, measurable attributes. These measurable attributes are nothing but the total cost, total revenue generated, total sales, right? So this measurable attribute contains these total values here, right? Aggregate values, right? So that is one of the attribute additional in the fact table. So this cube is nothing but the representation of the fact table, right? So when you, for the understanding only, we have written here the name of the cities. Actually here instead of city name there should be keys values, right? For Chicago city, for example, there is a C1 ID, C2, C3, C4. These are the city IDs. Then for a time also there will be keys T1, T2, T3, T4. For item also there will be keys values, that is I1, I2, I3, I4. But for understanding directly we have written the name here, but actually fact table contains the keys values, and along with this key value the aggregated values of the with different subjects, for example sales, then revenue generated, right, total number of products available, and so on. So a roll-up operation on location city, if you apply here, right, you will get here this more summarized data. So here roll-up operation is performed on the city, right? So city is converted into here USA, because this city-wise data we have aggregated or converted into the country-wise data. So if you observe this value for Chicago, this value is 440. For New York, it is 1560. So after applying roll-up operation, roll-up is nothing but the select query with the aggregate operation group by clause, right? So here we get the 2000, that is total sales in these two cities. That is nothing but the total sales of the USA country, right? So there can be multiple countries, right? But only two we have shown here for the understanding, right? So here, similarly, this Toronto and Vancouver we have aggregated into Canada, right? So this is the example of the uh, roll-up operation for the location dimension, right? So roll up operation on location from cities to the countries. I hope student you are clear with this. So roll up operation gives you the more summarized data. Similarly, you can get here instead of country, if you want state wise data, you can get by applying some group by queries or aggregation queries. Here is one example, another example of the roll up operation, right? Here only 2D data is shown for your understanding. Here, uh, where my first dimension is the time and second dimension is the temperature, right? So here my table contains the day temperature for multiple uh, uh, days here, right? So these are the temperature values. So in week one, week one, here this temperature is identified, this is identified, this is identified, and here also it is identified, this temperature values, right? So here, this is my summarized data in the data cube. So after applying roll-up operation, you will get the more summarized data. So this temperature values are converted into three different range: hot, mild, and cool. So for cool, the temperature range is 64 to 69. For mild, it is 70 to 75. For hot, it is 80 to 85. Right. So instead of daily temperature, now my manager want to analyze this temperature with respect to these three different categories, and that's why you can apply here roll-up operation to convert this detailed summary data into more summarized data. So now these values are summary of this cool range, right? So there are two times my in a week one, two times my temperature was cool, one time it was mild, and one time it was hot, right? So total how many entries are there? Four entries. Out of four, two are cool, one is mild, one is hot. Similarly, in the week two, these are the summary values for the week two of the temperature, right? So I hope student you are clear with this, right? So roll up operation groups the information by levels of temperature here. So we have used here concept hierarchy from a low level of the temperature into the high level of the temperatures, right? So levels we have identified cool, mild, and hot, right? So more summarized data we have identified here. Then see the drill down operation. Drill down operation is the reverse of the roll up operation, right? So it is a zooming in on the data cube, right? It navigates from less detailed data to the more detailed data, right? So here we find the more detailed data. As we discussed, my quarterly data you can convert into monthly data for the analysis with the help of drill down operation, right? So drill down operation will give you the more detailed summarized data. So it can be performed either stepping down a concept hierarchy for dimension or adding some additional dimension, right? That we discussed in the previous slide. So here is one example of the drill down operation on the quarter dimension, right? Drill down on the time from quarter to month, right? So here time is the one of the dimensions. So this is my original cube, right? So this is my original cube, and this cube, contains quarterly data, right? So after applying this drill down operation, you will get the more summarized data. So if manager want to analyze the monthly data instead of quarterly data, so drill down operation will help manager to retrieve this more summarized data. So monthly total sales will be stored in this each and every cell of the cube here, right? That will help manager people to analyze the monthly growth of the business, for example, right? So drill down operation is again a select operation, only this is a perform to retrieve the more summarized data. I hope student you are clear with this. Then this is another example, that temperature example. So here cool, mild, hot, these are we have applied for the roll up operation for more summarized, but see weekly data now we have converted into daily data, right? So after applying the drill down operation, you will get the detailed summarized data, right? Day wise summarized data here. So 10 days you can identify. For day 4, my temperature was mild here, right? For day 7, my temperature was cool here, right? So like that, my manager people can analyze by performing this drill down operation. Then slice operation is selected is similar to the project operation. Slice is a subset of the cube corresponding to a single value for one or more members of the dimension, right? So for example, if manager want to analyze only one particular quarter, for particular quarter, if manager want to analyze the sales of that business, right? So that we can do with the help of slice operation. So that slice operation will retrieve the slice of quarter 1 only, for example. So slice operation perform the selection on one dimension of the given cube, and that results in a subcube. Here we will see one example. This is my original cube here, right? And this slice operation we have performed on the Q1 here only, right? So slice for time Q1. So this slice operation will retrieve only the one slice of that cube, this one slice, this one complete slice of the cube, that is Q1, right? So all these values of this cube will contain the aggregated data for quarter 1, means aggregated data, total sales for Chicago of quarter 1, total sales of New York for quarter 1, but for the mobile item, right? Similarly for the modem item, for phone item, security for city wise, right? But all these values will be for the quarter 1 only. So this is also nothing but the select operation. Only my criteria is what here, time is Q1, right? So you are observing student here, we all are just discussing the select operation, only my conditions, right? Filtering criteria is different, right? So slice operation, only these names are in the data warehouse family, OLAP family, the names are given to these operations. Otherwise, these are similar to our DBMS queries only, right? Variety of queries we are using here to retrieve the data for the analysis, right? So here slice is functioning for the dimension time using the criteria Q1. Okay, I hope you are clear with this. This is another example, I mean, same example, previous example, only for the slice operation. So here we have retrieved the slice of cool only, cool, right? For dimension uh, temperature, my slice is for only cool category. Then dice operation is similar to this slice only, but it describes this subcube by operating a selection on two or more dimensions, right? So this dice operation shape looks like a dice, and that's why name is given dice operation here. So it is this subset of multiple dimensions, right? So here is one example. For example, implement this selection on time equal to day 3 or time equal to day 4 and temperature equal to cool or temperature equal to hot. To the original cubes we get the following subcube, right? So instead of all the days, only we have selected data for the day 3 and day 4, and instead of all the temperature categories, only cool and hot we have selected. So this will become the dice of my original cube, right? So here is the example for our cells data. This is my original cube, right? So subset of this cube is looks like a dice because we have applied this dice operation for Q1, Q2 Carter and Toronto and Vancouver cities only, right? So dice for location Toronto or Vancouver and time equal to Q1 or Q2 and item equal to mobile or modem. So we are selecting only two items, two quarter and two cities. So this is my example of the dice operation, which is the subset of the original cube, right? Like that also manager people can require for the analysis only they want to do the analysis on the subset of the data of the original cube, right? For the more detailed analysis. So that's why dice operation will help them to retrieve the subset of this data, right? Again, dice operation is the select operation, right? With the criteria, some specific criteria on the multiple dimensions, right? I hope student you are clear with this. So pivot operations is nothing but the rotate operation. So pivot operation is also called as the rotation here. So here, if you rotate this, this is my original cube, right? The front side of this cube is the temperature, side view of the cube is the time. When we rotate this, now my front has become time and side has become temperature. So same data you can represent here in the different view, right? So pivot is a visualization operation. Pivot operation is actually only for the visualization, not for retrieving the data, right? The same data you can visualize in a different view. So pivot operation is a visualization operation which rotates the data axis in a view to provide an alternative presentation of the data, right? It is used to provide an alternative presentation of the data, right? It may contain swapping of the rows and columns or moving one or of the row dimension into the column dimension, right? So here, after rotating this cube, we get this view of the data, right? So my manager can observe the data in a different views, right? So that will help to represent the same data in a alternative representation, right? I hope students you are clear with this. This is my example for the pivot operation. This is the slice. One of the slice we have retrieved from the data cube. Here side view is the location dimension, front is the item dimension. But when we rotate or pivot, apply the pivot operation on this slice, right? You get here front view as the location and side view as the item. Same values now we are observing here in the different view, right? So like that, if it is required, the top management people can use this rotate operation to see the data in a different point of view, right? So if we summarize all these operations, this is my original cube. All the operations are shown here in the slide. This is my original cube. This is my original cube. Here is the roll-up operation. If you observe, original cube is having here city-wise data. My roll-up operation converted this city-wise data into country data, right? More summarized data. This is my drill down operation. Drill down operation is giving you more detailed data. Same data now we are using to retrieve the more detailed summarized data. So this quarterly data is converted into month-wise data, right? So manager can analyze month-wise data. Here manager can analyze the country-wise data, right? Here dice operation is performed on my original cube to select the subset of the data. based on the location, multiple dimension. Here location is Toronto, Vancouver, time is Q1, Q2, item are home, entertainment and computer. Slice operation is for specific dimension, right? Because it is a project operation, right? So this is the one of the slice of this original cube, right? So manager also maybe require this one of the slice for the analysis, right? Right. And the time point of time, then pivot operation for this dice operation is shown here. The same data is represented into the different view, right? So this slide covers all these 5 operations of the data, right, of my OLAP operations, right? So I hope students you are clear with all these OLAP operation, and definitely there will be one question on the OLAP operation with example. You can write the answer here, right? So if it is for 2 marks, one operation, then in short you can define that operation and one small example you can give here. If it is for 4 marks, then detail you can explain and with the detailed explanation of the example, right? I hope you are clear with this. Thank you. Thank you.